2 of arithmetic and geometric. Again, we're not having a test. That test will be on your final, and I will pull it off and make it a quest grade, and then your final will be your final grade, but I'm not taking 2 grades. Okay, so the sum of a finite, what does finite mean?
Infinite.
No, infinite means infinite. What's finite mean?
Oh, not
Not infinite. Infinite. Arithmetic sequence. Okay, the formula is S sub n equals n over 2 times a sub 1 plus a sub n. Now, we did this in Algebra 2. We did all of this in Algebra 2. Okay, so I'm going to remind you what things are. So n in this case is the number of terms being added. A sub 1 is the first term. A sub n, guess what? Is the last term. Now remember last year when I told you about little Gaussen and his tutor said, I don't want to deal with you today. Go add up all those digits from 1 to 100. Yeah? And he started going 1, 2, 3, 4, and he got I don't know how far, and he's like, this is stupid. And he started going 100, 99, 98. Okay. Yep. And 97. And he's like, but wait a second. What is 1 plus 100 equal? What is 2 plus 99 equal? What does 3 and 98 equal? What does 4 and 97 equal? Okay, so if I have 1 to 100, how many pairs of number do I have? 50. Yeah? So if I just took 50 pairs times 101, I get 5,050, right?
Is that the answer?
Yes, that is the answer. So now let's look at the formula, guys. What's a sub n? Or a sub 1, the first term, right? 1. What's a sub n?
100.
The last term, which is 100, which 1 plus 100 is 101. And how many are there from 1 to 100? 100 divided by 2 is what? 50.
Wait, how do you know how many terms there is?
Well, from 1 to 100, that's 100 terms.
Well,
It just depends. Okay? So, sometimes it will tell you, like we did, add up the digits from 1 to 100. Or add up all the even numbers from 1 to 100. Well, how many is that? 50. Okay? What's the first even term from 1 to 100? 2. What's the last?
90.
100.
Oh. 2.
Yes?
Like 90.
So 2, and because even is arithmetic because you're adding 2 to every number, yes? So 2 plus 100 is 102. And 50 over 2, okay, is 25. Or could I just divide this and get 51?
Yeah.
Could I divide either one of them by 2? Yes, that's legal, right? I would rather do this because then I just go 25, 5, and 0. So what's the total? 2,550.
I don't even know what you just did.
Does it make sense that it's about half of all the digits? Well, actually, it's a yes?
Yeah.
Yeah. Okay. So that's how that works.
Ow, why would you do that?
But again, why would you do that? Okay. So that's the formula. You will see it in sigma notation. You will see it in lists of numbers. Sometimes you have to figure out what the last number is. Sometimes you have to figure out how many digits there are. So, okay, so here's an example. It says find the 150th partial sum of the arithmetic sequence 5, 16, 27, 38, 49. And it says of the arithmetic sequence. I'm not going to tell you if it's arithmetic or geometric. I always check for arithmetic first because it's easier. What's the difference between 5 and 16? 11.
Oh, yeah, shoot.
And from 16 to 27?
11.
11. So is it arithmetic? Yeah.
What's arithmetic?
Common difference. Video from Friday. Okay. So, common difference. So I want the 150. Oh, it says comma, dot, dot, dot. Point being is that is infinite, yes? But I said this is what? Finite. How can I do it?
Well, if I have to find 150th.
Did I make it finite?
Yeah.
Yes. Can I make anything infinite finite?
Yeah.
Yes, by giving you an ending point. But can I make something finite infinite? No.
It has an ending.
Okay, so I made it. So I'm finding S sub 150 because I'm finding the sum of 150 terms. Okay? Well, that would be 150 over 2. And then the first term, 5 plus,
We don't know.
The last term.
we don't know the last term.
50.
No,
No, it's not.
that's the number of the term. That's not what the actual digit is it? So we gotta do what we did Friday. So what we did Friday was a sub 1 plus n minus 1 times d, right? And we want 150. So what's a sub 1? 5. So 5 plus n minus 1, and the difference was 11. Forgot my a sub n. So a sub n equals, let's see, 11n. And that would be 5 minus 11, right? So negative 6. So I just wrote my formula, my definition, my rule, whatever you call it, right? Now I need to plug in what? 150. I don't know why I did that, sorry. So I have a sub 150 equals 11 times 150 minus 6.
How is it 11?
Because you distribute.
Yeah. Oh, wait, no, 5 isn't. Never mind. I'll see another 5.
Okay. So 1500150. I get 1650 minus 6. You get 1650?
Yeah.
Okay, so 1644. So a sub n is 1644. So sometimes you have to figure that out. So half of 150,
Wait, wouldn't it be negative 75?
where is it going to be negative?
11. Yeah, 75.
11 would not be negative
Why not?
because its n's positive. This n would be negative, and that's why it was negative 6. It would be 5 plus 11n minus 11. Okay, 75?
75.
And then,
Just kidding.
okay, 1649. And then I get to what? Multiply it. So you multiply it and I multiply it.
You mean 4, 4?
No, you have to add 5
Why?
because it says plus 5.
You're right.
I got 123,675.
Got 1, 2, 3, 6, 7,
Is it 6, 7?
10.
Yeah, I did it right.
Okay, so are we gonna have to work with some of our numbers sometime?
Yeah.
Yes. Okay.
Where did you get this number? 8,000.
I multiplied by 70 and then I multiplied by 5. That's how I multiply. Because 70 plus 5 is 75.
Okay, so you just multiplied by 75 though.
Yes. Yes. I just do it differently. Okay. 1, 2, 3, 6, 7, 5. Now, summation notation, the same thing. Summation notation. Is with the sigmas. No, I'm trying to write it really nice. And so it's trying to fix it when I'm writing. We'll just let it fix. Okay, so that is a sigma. That is what it looks like. So down here, they usually use I. We used N. I'm gonna put I equals 1 to N of f of x. Okay. That f of x is your formula, your rule, or your definition. Got it? So
Like the
right
one we
here,
found?
like right here, this, right here. Why? This right here would go right there. That's that f of x. Okay? So what this is saying is it wants to know, sigma means sum. Okay?
What's under the sigma thing?
I
So,
equals
I guess.
1. I equals 1.
Lower limit, upper limit.
There, guys. I don't want to get that other stuff off the board, sorry. Because then I have to rewrite it. Okay. So, I equals 1 is your lower limit. Remember this now. N is your upper limit. So what it means, so if I just would have written the one I just did, okay, this problem right here that we just did, in summation notation, I would have had the sum from I equals 1 to 150 of 11I minus 6.
Does I equals 1 just stay the same?
I is just, it can change. It could be 5, 6, 7, 8, 9, 10.
Then I won't have to do anything down there. Like, plug anything in right here. Like,
If you wrote it yourself, but if we write it ourselves, we always write I equals 1. Sometimes they will say I equals 10 to 60.
I'm saying I won't have to find it myself.
No, unless you write them, but it will be always I equals 1. Okay, so all we did was change the N in the formula up here to an I because I used I right here. If I wanted that to be an N, I would make N equals 1. Make
Okay.
sense?
Hold on. What's on top of that?
150.
Can you just give a different example?
No, I want us to see what we just did. Okay, from All that means is I want the sum if I'd plug in 1. A sub 1 is found by plugging in your lower limit. A sub n is found by plugging in your what? Your upper limit. Okay? So that means just find the sum. So from 1 to 150 is how many things?
Probably 149.
Nope, it's 150. Okay, now, wait. You subtracted. What you found was gaps between the numbers.
Oh.
But if we plug in 1, those actual things. So that was the 150 over 2. We find a sub 1 by plugging in 1. Well, if I plug in 1 to this equation right here, I get 5.
Why is 150 over 2?
Because there's 150 things we're adding. I will give you,
yeah.
okay? Plus, a sub n is the last where you plug in your upper term. So if I plug in my upper term, we did it and got what?
1644.
Ooh. 1644, correct?
I need like
So 1644. And we're going to get the same answer. It is just another cleaner way to write these. So here's an example. The sum n equals 51 to 100 of 7n. Now, here's the secret to finding this n right here. Secret. You take the upper minus the lower plus 1. Every time it works. Because what did you do? You said it was 149 from 1 to 150 because you subtracted them, yes? So if you would take 150 minus 1 plus 1, you get 150. So upper minus lower plus 1.
what n are you talking about?
What I'm pointing to right there. In the formula, right here. Where's the formula? In the formula right here.
Oh, obviously, yeah.
Okay. Yep, I'm going back.
49.
So,
I'm confused because I thought I was at the bottom.
okay. They used n in this problem.
So it can be
This
any
used
number.
I. It's just a variable. But whatever that variable is has to be what you have in the problem. Like, this is I, so this was I. This is n, so that's n. Because that's what you're replacing.
Okay.
Okay? So,
Just an imaginary number.
so upper minus lower plus 1. So 150, or 100, sorry, minus 150 is 49, wait,
49.
49, plus 1 is 50. So we are adding 50 things. So it's 50 over 2. Now a sub 1, we plug in the lower limit. Right? So 7 times, what's our lower limit?
So 357.
51. So 357. A sub n is upper limit. So 7 times 100 is what? 700.
What are you doing?
I'm doing the formula.
So lost now.
I'm doing the formula. Do you not have the formula on your paper?
No, I just,
No,
I didn't,
did.
I don't.
Yes.
Okay. The formula is n over 2 a sub 1 plus a sub n.
Okay, I know.
Yes?
Oh, okay.
I'm doing more work than I've ever done. Didn't even give you guys that much
that's
work.
why I'm confused.
Because, well, the problem is you guys don't know where anything comes from.
No,
Well, you're
I'm
so
doing it
much
right here.
work.
Okay.
Again. That's
So-
confusing me.
Well, then don't write that down then. But some
No.
people don't. Okay, so we got 1,075, right? 25 times 1,075, or 57. And then you do the math.
And that's our 100th term
No, that's the sum.
of
The 100th term was you plugged in 100 and got 700. The 100th term is the sum of the 51st term to the 100th term is whatever our answer is. I got 7,399. What'd you guys get? Oh, I did not get that answer. I did not get that answer. Because that would not make sense. Okay, I got 26,425.
That's what I got.
I forgot to put my 0 when I multiplied by 20.
Good. Hey, 26425.
2642, yep. Okay, so then we got 2 more formulas.
What?
We got 2 more formulas.
You're on
So far, in the 2 days of notes, you should have you should have definition rule of an arithmetic and then of a geometric, right? There's geometric.
Arithmetic one, I don't have the geometric.
Okay. And then we have the sum of a finite arithmetic, right? Okay. Now I guess if you want to count sigma notation, but that's not really a formula, that's just how to write it, correct? So now we have to go geometric. Now, I didn't give you a sum of a finite arithmetic, did I? No. I mean infinite. You know why?
What?
What does arithmetic mean? You
Um,
add or subtract the same thing over and over and over. Lily? Okay, we add or subtract the same thing over and over and over, correct? And this speaker must be on. Okay, when I add something, I'm going infinite, yes? Is there an end? Is there ever an end to infinite?
No.
No. So could I ever add up all the digits of an infinite? No. Okay, but I'm going to tell you when we get to geometric, we can do infinite. I know. Okay, but first we're going to go with a finite. So the sum of a finite geometric.
Are we just putting it all together now?
No, we're just going geometric. We did arithmetic sum, now we're going to geometric sum.
I'm just gonna have my old notebook for this one.
We didn't do this last year.
I'm fixing it. It's the black speaker I think it's behind the red one. Can you just shut it off, please? Is it back there? Okay, thank you. Okay, is S sub n equals a sub 1 times 1 minus r to the n. That's an exponent. Do I need to write it bigger so you
No.
can see it?
Nope.
Some people like r to the n over 1 minus r.
So what is R?
Like circles.
Geometric is common ratio.
Idiot.
Common ratio. Ratio. Friday we did common ratio.
Circles.
Common division.
Okay, so sum, there we go. That's a r's common ratio. N is the number of things you're adding. A sub 1 is the first thing. Yes? Same as the other one. So find the sum. Oh, this one's using an I.
Is it R? to
I.
N?
Yes. Equals 1 to 12 of 4 times 0.03 to the I minus 1.
0.03 or 0.3?
I said 0. It's 0 point. It's 0.3. It's right. Okay. Now remember from Friday, if you do not, geometric sequence was a sub n equals a sub 1 r to the n minus 1. Correct?
Yeah, sure.
Okay. So our formula says s sub n. Well, from 1 to 12 is how many? 12. That one's an easy one, right? It won't stay. Okay, so a sub 1 I get by plugging in 1. So a sub 1, I get 4 times 0.3 to the 1 minus 1, which is 0. Anything to the 0 power is 1, and 1 times 4 is 4. Okay, a sub 1 is not always the thing. Like, if you start at 0 and not 1, it's not going to be 4. You got me? Does everyone understand me? Do the math.
Wait, so you all did it again?
I plugged in 1 to this formula right there. So 1 minus 1 is 0. So 0.3 to the 0 is 1. 1 times 4 is 4. Okay, I know you guys see 4 right here, don't you? Okay, but if we start at 0 or we start at 6, is that going to be different than that first number? Yes. The only reason it was the first number is because we started at 1. Okay? So I have a sub 1. I have r. R is always the base of the exponent. So what's r?
One.
What's r?
R2. Wait, no.
Look at the formula. What is the r in this formula?
Oh, 0.3.
0.3. Thank you.
Wait, why is there equal 4 at the end?
Because a sub 1 is 4. We did the math. We're just getting what we need for the formula right now. Okay, and what is n?
12.
12. Because 12 minus 1 plus 1 is 12. Upper minus lower plus 1. Yes? Okay. So now I plug it into the formula. The formula says a sub 1. What was a sub 1?
12.
4. I can't. It won't. It keeps going back. Maybe if I zoom it in, I don't know. Okay. That's ridiculous, but oh well. Okay, 4. Then what else on the formula? Parenthesis, 1 minus r. What's r? Yeah, that's ridiculous. What?
0.3.
0.3. So 0.3 to the 12th over 1 minus 0.3. Okay, well, 1 minus 0.3 is 0.7.
Why is it 2 to the 12 if it's 1?
Because that's the formula.
But it's 12 minus 1.
No, it's 12 minus 1 plus 1. Upper minus lower plus 1.
Yeah, I see that. It's 12.
So it's 12.
Yeah, I know, but what?
So it basically just be
What
12
I
minus
is
1.
12. It's 12 minus 1, is it not?
Yeah, and then
No. This is for n. For n,
Oh,
remember upper minus lower plus 1. We're not plugging it into the formula. Okay. So 1 minus 0.3 is 0.7. So that gives me 4 over 0.7 times 1 minus 0.3 to the 12th. Okay, well, I don't know 0.3 to the 12th. Do you? No? Okay, so we would have to use a calculator at that point. But I think we could move this one and move this one and 40. So without a calculator, your answer to this is 40 over 7 times 1 minus 0.3 to the 12th. And that's what you would leave for me. Do you understand? Okay, with the calculator, when you did this, the answer is approximately 5.714. Okay? But for me, this is what you would answer because you can't do it. But now if you have 1/2 to the third, can you do 1/2 to the third?
No.
Yes, that is 1/8. I would expect you to do the math.
1/8, 1/2 to the third.
Yes, what's 2 to the third? 8. What's 1
I
to
would
the
have
third?
not did that. I would have put 6.
Okay. Now, that was the sum of a finite, yes? But I'm going to tell you we can find the sum of an infinite. Now, how?
I think you're variable.
Well, common ratio means I multiply and multiply and multiply, right?
Wait, do we have
But what kind of number could I multiply by that ends eventually, kind of? If I keep multiplying by 2, does it ever end?
No.
No. What about 1/2?
Yeah.
Technically, 1/2 to the 8 billionth is a number, yes?
Mm-hmm.
But it's pretty close to a 0, isn't it?
Mm-hmm.
Right? So you can only do this. Can do only when R is between 0, is greater than 0, less than 1. And that's the absolute value. I would assume you would know that. Okay, because when I square or take something to the 28th or whatever of a fraction, my denominator is getting larger and larger and larger and larger. And is my numerator getting large as fast? No, it will eventually approach a number close to 0. So I will be adding 0 every time. So is the number kind of truncating? It's called a limit. So the formula is as follows. S sub n, and I should have made that a sub and I didn't. I yell at you guys, don't I? Equals a sub 1 over 1 minus r. Okay, remember on your final, you'll have these formulas. You'll just have to know which formula is which. Okay, now, if I look at this formula up here, how is it similar?
Base and 1 minus r.
Right, the 1 minus r in the denominator, yes? Now, if that numerator, if I say my ratio is 1/7, and I said it's eventually going to approach 0, yes? So what's 1 minus 0? 1. And then what's 1 times a sub 1? A sub 1? That's why you get that formula. It's the same formula, just basically 0. So you use it the same way. The assignment you got on Friday is the same assignment. It had summation stuff with it.
Was it paper or was it on book?
It's a book.